this problem, we want to calculate the mole fraction for a concentrated solution of aqueous ammonia. And concentrated ammonia is 28% ammonia, and it has a density of 0.90 grams per mil. So we can choose any sample size. We'll do this the easy way, and we'll choose 100 grams. If we have 100 grams, there's 28 grams of ammonia, and there will be the remaining 72 grams of water. That is 100 minus 28 would be 72. Now we need to convert these to moles. These are the grams. So we divide by the molar mass, which is 17 grams per mole for ammonia. I don't need a lot of significant figures because my original question only had 28%. And I divide this by 18 grams per mole, the molar mass of water. Get out my calculator. This is 1.65 moles of NH3. This is 4.0 moles of H2O. That only has 2 sig figs, but I'm keeping it there because it's a 5, and we'll just top it off at the end. Okay, now what do I know? I know the mole fraction of the ammonia is equal to the moles ammonia. Remember, we use small n as the symbol moles, over the moles total, which is the moles ammonia plus the moles water, which is equal to 1.65 over 1.65 plus 4. I could have added that as 5.65, but I wanted to show it. And now I get out my calculator, and I get 0.29. And since the original question was in 2 sig figs, my answer's in 2 sig figs. And you ask yourself, does this answer make any sense? Well, the mole fraction and the mass fraction are very close to each other. And if I look at the molar masses, one is 17, one is 18. And since these are very similar, the mole fractions and the mass fractions will be similar. If these were very different, then the mole fraction would be very different than the mass fraction.